This is Mr. Müller. Mr. Müller is an industrialist in the Aachen region and manufactures plastic profiles with the help of an extrusion line. Mr. Müller is planning to produce a new profile and therefore needs a new die. In fact, he already has a new order lined up, so he is in need of a quick solution to realize the new die. He calls his die maker, but both of them realize that it would take a couple of weeks to tackle this task in the conventional way. Mr. Müller comes up with a different idea. He remembers that an institute of the RWTH Aachen University is doing research in the area of extrusion dies. He decides to call Mr. Schmidt to ask whether there is a possibility to manufacture the new die in less time. Mr. Schmidt is an engineer researching at the Institute of Plastics Processing, IKV, which is part of the Cluster of Excellence Integrative Production Technology for High-Wage Countries. Mr. Müller explains his intentions to Mr. Schmidt, who confirms that he can help him to realize this new die. Together with the Cluster of Excellence researchers of the Chair for Computational Analysis of Technical Systems, CATS, the new flow channels of the die are calculated through flow simulation and optimization. The goal is to fulfill the required quality requirements of the die already during production so that no complex reworking is needed. Thereby it is possible to save time and reduce costs. Owing to the interdisciplinary teamwork of the Cluster of Excellence, the researchers provide an innovative solution for the manufacturing of Mr. Müller's new die. The IKV passes the optimized dataset of the die to the Fraunhofer Institute for Laser Technology, ILT, to produce the new die by selective laser melting. The SLM denominates a manufacturing process in which a material in powder form, either metal or plastic, is melted locally and in layers due to laser radiation. This procedure is repeated several hundred times. That way, a 3D component is printed layer by layer. After the solidification process, a solid material layer is formed consisting, for instance, of aluminum or titanium. Mr. Müller's new die for his production machine is manufactured in the same way. So Mr. Müller is able to use the new die straight away to produce the new profile. In general, SLM as additive manufacturing method provides benefits for the production technology of the future. With the conventional procedure, the costs per piece for small lot sizes are comparatively high. In contrast, with SLM, the costs per piece are independent of the produced lot sizes. Therefore, components with small lot sizes can be produced more cost-effective compared to conventional manufacturing. The Cluster of Excellence aims at increasing the productivity of SLM so that it also guarantees greater cost advantages for bigger lot sizes. Also, the SLM enables the development of new business models for products with a high degree of individualization. In the case of conventional manufacturing, piece costs increase with increasing part complexity. The SLM, on the other hand, represents a cost-effective alternative since time and effort needed for manufacturing is only dependent on component volume, but independent of part complexity. Therefore, innovative products with previously impossible integrated functionalities can be realized with additive manufacturing methods like SLM. This manufacturing method represents only one section of the Cluster of Excellence Integrative Production Technology for High-Wage Countries. In the context of globalization, manufacturing in Europe is exposed to a new framework. The Cluster of Excellence meets this challenge with interdisciplinary research initiatives, which are supervised by scientists from the areas of mechanical engineering, material sciences, computer sciences, mathematics, economics, and psychology. Together they face the fourth industrial revolution, which is driven by an increasing involvement of information and communication technology. This change is enabled by intelligent production systems, individual machine and control components for a more dynamic and flexible production technology, from continuous data and software solutions to holistic self-optimizing factories. The research projects of the Cluster of Excellence focus on the individualization, virtualization, integration, and self-optimization of production technology.